Hey grade 6s, and welcome to our talk on symmetry. We're going to start with the concept that you understand from previous grades. And basic symmetry, as you know it, means that we can cut an object in two. So for example, if we cut this object, this square, into two shapes, we've got two equal halves. And that means that you could actually take one half and fold it over to the other half, and it covers it entirely. So this is what we call bilateral symmetry. Now bilateral, if you look at the actual word, it starts with bi, which is a prefix that means two, and it means that you have two halves. So bilateral, you've got two halves that fold together, and they are identical on either side. So if we look at our square again, we can make more than one bilateral symmetry. There's another one that we can go across the side. We can cut across the diagonal, and we can cut across the other diagonal. And so you end up having four lines of symmetry in a square. And you'll notice as well that a square has four sides, and there are four lines of symmetry. Well, let's see if that works out with a hexagon. So with our hexagon here, if we were to cut it in half, so there you go, one side can fold over on top of the other. So there's one line of symmetry. You can cut it down the center like we did with the square. Good, there's two. We can go diagonal. There's three. Do the other diagonal. Four. And this one will just move slightly. It's slightly off. There we go. And maybe this one's a little off too. Okay, so we've got four lines of symmetry, but there are more as well. So we can cut it in half going this way. So we've got five. Oh, and there's another one, six. And cut it in half going that way. So a hexagon has six lines of symmetry, and a regular hexagon, where all the sides are exactly the same length, has six sides as well, and six equal angles. So in bilateral symmetry, if you're dealing with a regular object, the number of sides it has will also equal the number of lines of symmetry. Now let's see if this works with more regular objects. We're going to look at some letters here. And let's look at this A to begin with. Do we have a line of symmetry there? Can it go across the side? No. But it can go straight up and down. And with that line of symmetry, you can take one half and lay it on top of the other, and yes, it is. What about the B? Well, you can't go down the top, but you can go through the middle, and there's a line of symmetry on the B. Are there any others? No, there are not. So A and B both have one line of symmetry. Well, what about the N? Can we cut it down the center so that one side folds into the other? No, we can't. So that's not going to work at all. What about if we take one across the center that way? Can we fold it in half across that line of symmetry? No, we can't either. So that's not going to work. So the letter N actually has zero lines of symmetry. They don't have any. Well, let's take it down to maybe some real life objects, and let's take this face on the left hand side. So the human body is actually symmetrical, and a lot of animal bodies, and in fact a lot of plants, have natural symmetry. So here you can see that in this picture of this lady, if you draw a line down the center, one side pretty well mirrors the other side. It could be folded in half to create it. So there is a line of symmetry in natural objects and in nature, and you saw in class too there were a number of nature pictures where symmetry exists. So what I would like you to do, this is your assignment for the night. It says list all letters of the alphabet on a table showing the number of lines of bilateral symmetry in each letter. And you can see here that I've started it out. We've got 4 columns. So the objects with 0 lines of symmetry, and we can see our N belongs there. Letters with 1 line of symmetry, we've got our A, B, and I added the M there. Can you find any letters that have 2 lines of symmetry, or any with 3 or more? And we'll compare notes tomorrow on that. The other thing that you can do with symmetry is, we've been talking about internal lines of symmetry. You can also have an external line of symmetry, where you have 2 identical objects and you have a line in between them, so that if you fold the one half onto the other, we get a symmetrical object as well. So here you can see our ruler is down there, all laid out, and if we draw a line between these 2 objects, measure it out and draw it down, and there we go. The one half, it's equal distance from one side as it is from the other. This is an external line of symmetry. There's another type of symmetry that shows up when we deal with the letter O. And here we've got a line of symmetry. We could just draw it down the center. One half folds onto the other. The same thing can be true for going through the half. Can we go through the diagonal? Yes, we can go through the diagonal that way. We can go through the diagonal the other way. In fact, we can even divide each of those diagonals into the diagonals. And here you go there, that it keeps going and going and going. In fact, the letter O, or 0, has an infinite number of lines of symmetry. You could keep cutting it smaller and smaller and smaller and smaller, and you would never ever get totally to the end. So internal lines of symmetry with a circle, it's an infinite number. It goes on forever. What about with something like a triangle? Now, I've got a triangle here, and you'll have to forgive me, I couldn't find an equilateral triangle, but this will do fine. So you've got a triangle here, and you see the number 1 on the top. Well, what happens if we start to rotate it? Well, if you rotate it and you have equilateral triangles, you'll find that they go right over top of each other. And this is a different type of symmetry. This is a symmetry called rotational symmetry. And so we've turned it once and it goes over itself. We can turn it again, and if we get it lined up again, if it was equilateral, there would be a second one, and we can turn it yet a third time, and it goes back to where it was to begin with. So an equilateral triangle will have 3 turns where it falls into itself, and these are called the order of rotation. So a triangle has an order of rotation of 3. Let's take a look at some other objects. Okay, here we've got our hexagon again. This one will work. So we start to rotate it. Oh, there's 1 rotation. So 1 order of symmetry, 2, 3, where it fits over itself, 4, 5, and 6. So we saw earlier that a hexagon has 6 lines of symmetry. It also has an order of rotation of 6 as well. And finally, let's look at another object here. Now, just by looking at this object, what is the order of rotation of this object? Well, let's find out. As we turn it around, does it fit exactly into itself? No. No, in fact, you have to go all the way around 360 degrees to get it to fit on itself. But we do not have, there's no such thing as an order of rotation of 1. So we say that this object has no rotational symmetry, or an order of rotation of 0. And if we go into our quick review, so we've looked at 4 things. The first thing is there are 2 types of symmetry: bilateral symmetry and radial symmetry, or rotational symmetry. Number 2, symmetry can either be internal, which is inside the object, in which we have the lines of symmetry, or you can have an external, or outside outside the objects, between the two objects. The third thing is objects with internal lines of symmetry are described by the number of lines of symmetry the object has. And the last point, rotational symmetry is described through an order of symmetry, and there's no such thing as an order of symmetry of 1. So I hope that helps you understand symmetry, and good luck.